So in this question, we're interested in the range of values of x for which the following functions are decreasing now, and x is an element of the real number set again. Our steps are the very same as when we're interested in when a graph is increasing. Step 1, we differentiate. Step 2, we let the derivative this time be less than 0 because we're interested when it's decreasing. And step 3, we solve for x. So step 1 is always going to be differentiate. Step 2 will be let the derivative be less than 0 if it's decreasing, and let the derivative be greater than 0 if it's increasing. So step 2 is the one that can change, but step 3 again will always be the same, solve for x. So our first function is 2x cubed minus 9x squared plus 12x minus 5. Now when we differentiate a cubic function, we get a quadratic. So we're going to start off by differentiating the 2x cubed. We're going to bring the 3 down in front, and 3 by 2 is going to give us 6, and reduce the power by 1. 3 minus 1 is going to be 2, so we get 6x cubed. So we can clearly see before we go any further that the derivative of our cubic function will be quadratic. Then we're going to differentiate minus 9x squared, bring the 2 down in front, minus 9 by 2 is minus 18, and reduce the power by 1. 2 take away 1 is 1, so it's just going to be minus 18x to the power 1, which is just minus 18x. Differentiate plus 12x, we're going to just cancel out the x, and we get plus 12, and differentiate minus 5, we cannot differentiate a constant because there's no x value, so we just cancel that out. So again, the derivative of 2x cubed is going to be 6x squared. Bring the 3 down in front, 3 by 2 is 6, reduce the power by 1, 3 take away 1 is 2. The derivative of minus 9x squared, bring the 2 down in front, minus 9 by 2 is minus 18, reduce the power by 1, 2 take away 1 is 1, x to the power 1 is just x. 12x, we just cancel out the x, and minus 5 is constant, so we cannot differentiate that. So the derivative of our function is going to be 6x squared minus 18x plus 12. So step 1 was differentiate. Step 2 is going to be to make the derivative less than 0, because we're interested in when it's decreasing. Now there's a few ways that you can go about doing this. In this particular example, they have divided across by 6, so they can see that 6 is going to be the HCF, the highest common factor of 6 minus 18 and 12. So they've pulled out the 6 there. 6 into 6x squared goes x squared times. 6 into minus 18x leaves us with minus 3x. 6 into 12 goes twice. And then we can just cancel out the 6 because technically we've divided across by 6. And that's going to leave us with x squared minus 3x plus 2 is less than 0. Remember, it's a less than 0 because we're decreasing. But alternatively, if you couldn't have divided across by a highest common factor, you could have used the quadratic formula to solve. So labeling the coefficient of x squared as a, the coefficient of the x as b, and the constant as c, and subbing it into the quadratic formula, also known as the minus b formula, to solve for x. But in this case, I have a quadratic, I'm letting it be less than 0, I'm going to factorize, and then I'm going to solve. So if we want to factorize a quadratic, what we're going to do is, first of all, bring down the x into the front of both brackets. So x by x gives us x squared, so that's why we have an x in the front of both brackets. Then we have a look at the sign here. We see it's positive, so we know that these signs are going to be the same. And then we have a look at this sign here, and we see it's negative, so we know that they're both going to be negative. Then we have a look at the 2 at the end, and we say, well, what are the factors of 2? Just 1 and 2. So we're going to use 2 and 1. And when we add them together, minus 2 minus 1, we should end up getting minus 3, which we do. So if we want to factorize x squared minus 3x plus 2, we get x minus 2 times x minus 1. So these are the factors. We were asked to solve. So what we can do is say, well, if x minus 2 is equal to 0, x is equal to positive 2. If x minus 1 is equal to 0, x is equal to 1. So our x values are going to be greater than 1, but less than 2. Now, if we were to draw out our function, so x squared minus 3x plus 2, we know that it's a U-shaped graph, first of all, because it's a quadratic, because it has an x squared. We know it's going to be a U-shaped graph. And what we've done by finding x is equal to 2 and x is equal to 1, we found the roots of our equation. So we found the 2 points at which the graph crosses the x-axis. So we can label this point as 1 and this point is 2 on the x-axis. Now, we're interested in when our function is decreasing. So this is basically where our y values on our y-axis, where our values on our y-axis are going to be negative. So basically anything that's below our x-axis are the points at which our y values would be negative. So for example, this point here would be -1 on the y-axis, -2 on the y-axis, -3 on the y-axis, and so on, moving down to -infinity. Anything above the x-axis has y values that are positive. So if we're interested in where our function is decreasing, we're looking for any points on our graph that are below the x-axis. So our graph is decreasing for x values between 1 and 2. If we were interested in where our function was increasing, not decreasing, increasing, it would be any points on our graph that are located on the positive part of the y-axis. So we could say that this function is actually increasing for x values less than 1 and x values greater than 2. But we were interested in where it is decreasing. So x values from 1 to 2. And I'm going to show you this on a graph in a couple of minutes. Okay, our next function was x cubed minus 48x. Again, we want to differentiate. Let the derivative be less than 0 because we're decreasing, and then solve for x. So x cubed, we want to differentiate that. We bring down the 3 in front and reduce the power by 1 to get 3x squared. And minus 48x, we just cancel out the x to get minus 48. So again, the derivative of x cubed minus 48x, we bring down the power in front, so we get 3x. And we reduce the power by 1. 3 take away 1 is 2. So the derivative of x cubed is 3x squared. Minus 48x, we just cancel out the x, we get minus 48. So step 1 was differentiate, which is what we've done. Step 2, let the derivative be less than 0, because we're interested in where it's decreasing. So we set 3x squared minus 48 to be less than 0. We're going to bring the minus 48 over the inequality sign to get positive 48 on the right hand side. We divide across by 3 to get the x squared on its own. 48 divided by 3 is going to be 16. And if x squared is going to be less than 16, then we just want obviously values of x. So the square root of 16 is going to be plus or minus 4. So the x values greater than minus 4 and less than positive 4. These are the points on our graph at which our function is decreasing. So we had x squared less than 16. So the squared comes over the other side and becomes a square root. The square root of 16 is positive or negative 4. So our function is going to be decreasing at x values greater than minus 4 and less than 4. So let's have a look at these cubic functions on a graph. So we found that the function 2x cubed minus 9x squared plus 12x minus 5 is decreasing for x values greater than 1 and less than 2. So this is our cubic function. We can see it's got an S shape, and we know that it's going to have an S shape because it's got an x cubed value here at the start. So we can clearly see that our graph is increasing up as far as x is equal to 1 because it's going uphill, because we read a graph from left to right just like we read a book. It's going uphill, then it levels off, so this would be the maximum point of our cubic function. Then it starts to decrease down as far as x is equal to 2, where it levels off again. This would be the minimum point of our graph. And then it starts to increase again at the point x is equal to 2. So it's very obvious to see when we draw out the function. It's increasing up as far as x is equal to 1. So for x values less than 1, it's increasing. Then it's decreasing down as far as x is equal to 2, and then it starts to increase again. So we're interested in where it is decreasing, and we found it to be when x is greater than 1 and x is less than 2, and it's very obvious to see that in between the points x equals 1 and x equals 2 on our x-axis, we have a decreasing section of our function. So here we have our second cubic function, so x cubed minus 48x, and again it's an S-shaped graph. And we found that when we did step 1, 2, and 3, we found that our function was decreasing for x values greater than -4 and less than +4. So we can clearly see from our graph that our function is increasing. It's going upwards right up until this point, where our x-axis would be about -4. Now I know -4 is not written in there, but if this is -5, then that point there is about going to be -4. So that would be the turning point of our cubic function, also the maximum point. Then we can see that our graph starts to decrease, so it starts to go downhill at x is equal to -4, right down until about x is equal to +4. So our graph is then decreasing, which is what we're interested in. And then again we have another turning point in our graph, and this is also the minimum point of our graph, where our graph starts to increase again. It starts to go uphill. So we were asked, where is our graph decreasing? We followed steps 1, 2, and 3 to find our x values greater than -4 and less than +4. And we can clearly see that at -4 on our graph, at the x value of -4, our graph starts to decrease, it starts to go downwards. And then at +4 on our x-axis, that is the point at which it starts to go upwards again. So our graph is decreasing for x values between -4 and 4.